So statistics, first thing we're going to look at is the measures of central tendency. And I'm assuming that you've probably heard these three words before: the mean, the median, and the mode. They are all different kinds of averages. Generally, when someone says, what is the average of a group of numbers, you're usually talking about the mean. That's what we generally consider to be the true average. Whatever the terms are, you add them all up and then divide by the number of terms. That's, like, again, that's one we use most often. However, sometimes the median will be the most applicable average for us to use. The median is the number that's right in the middle. So if you average all the numbers from smallest to biggest and find the number that's right in the middle, that's called the median. The times where you would say the median is a better indication of an average is when there is an outlier. In other words, for houses, like if you're looking for the average house value in a city, they don't tell you the mean. They always tell you the median value. For example, let's say like in a certain neighborhood, there's a house for $300,000. There's another one for $350,000, $360,000, and then there is like an $800,000 house. It happens sometimes, right? Like in a neighborhood, generally the houses are kind of close to each other, but occasionally you get one that's worth a lot more. Somebody put a lot of money into it. Maybe it's a double lot or something. And so if we found the mean of this list of numbers, that mean is probably going to be something like $500,000 or $400,000, which is bigger than almost all of the other numbers. This 800,000 skews the result a little bit. So in a case like this, where there's a potential for an outlier, like a house that's worth a lot of money, you usually use the median. And then our last measure of central tendency is the mode, the most often. You'd use this if there's an outlier as well, but if there's a number that shows up a lot. So if like the mode is the most often, if the number like 5 shows up a bunch of times, we might say, hey, the mode of this is 5, and then talk about its relevance. They're all kind of important depending on the situation. Two more vocabulary terms here. We have our range and IQR. The range is the difference between the smallest number and the biggest number, so that we can see how spread out these numbers are. And then the IQR is the interquartile range. So IQR stands for inter means between, quartile is between the first and the third quarter. So like the numbers that are in the middle, and then the range, the difference between Q3 and Q1. We'll talk about like this idea of Q3 and Q1 here in the next part. But the interquartile range tells us like where are most of these numbers clumped together in the middle? Like how big is that spread between those numbers? Before I go into this example one, when you take a standardized test, how do you normally get your scores back? Like if I took say the ACT test, does the test tell me, hey, you got 37 out of the 50 questions correct? No, like that's not how the score is reported, right? It doesn't even tell you the percent. It doesn't tell you, hey, you got 86% of them right. What's the term that's used when you compare your scores to other people, like in a standardized test? Do you know? Mm-hmm. Yeah, so they'll tell you like how you compare to other people. Like if you got like they might say 97, like that means you scored better than 97% of the other people that took it. You know what that's called? No. Percentile. Have you heard that term before? Percentile. And that's what Mia was talking about. Like if you got the 97th percentile, that doesn't mean that you got 97% correct. It means you did better than 97% of the people that took that test, which means obviously you were in the top 3%, which is pretty amazing. That gets back into this quartile. So if you scored at, say, the 75th percentile in a standardized test, that means that you scored better than 75% of the people. You would have been in the third quartile, like not right in the middle, but you would have been like right at the 3/4 mark then. Let's look at more specifically with this. Here's a list of numbers. We'll get more into the quartile in a second. But with this list of numbers, we want to find out these 4 pieces of information: the mean, the median, the mode, and the range. So on your calculator, can you first of all find the mean for that list of numbers? So for the mean, you should be adding all those numbers together and then dividing by how many terms are listed in this one? 11. So add them all up, divide by 11. And I think it comes out to an integer, like a non-decimal, right? 62. So there is our mean. And when you're calculating the median, you could rewrite all these numbers again from smallest to biggest, and it's okay to do that, but I get a little lazy on those, quite honestly, and I'm looking for another way to do that. So what I like to do is just start crossing numbers off. For example, I'm going to cross off what I think are the two smallest numbers right away. Then I'll cross off the two biggest numbers. So now I've gotten rid of the bottom two and the top two, and I'm going to try to work my way to the middle. And I put my slashes in different directions. You don't necessarily have to do that. Like slashes in one direction are starting at the bottom, slash in the other direction is going from the top. That's not necessary, but again, I just kind of organize that way. I'll take two more from the bottom. I'll take two more from the top. Now I'm getting a little bit closer to the middle. The smallest is 59, the biggest is 82, and I'm left with a median then of 70. So just crossing off back and forth, I can get to my median. As far as the mode goes, do you see any numbers that are repeated more than once? You can think about that as you're crossing them off. What numbers showed up more than once? All right, so 32 mode. Anything else with that? 94. 94 also shows up twice, and it's okay to have two modes. 32 and 94 are both considered the mode. And then for the range, we're going to take our biggest number that we have minus the smallest number that we have, subtract them, and we see that the range is 71. That tells us how spread out these numbers are from each other. When you're ready, go ahead and move on to that second one. I think the mean comes out to an integer again, 64. And then doing the median again, median comes out to, I believe, 62. What's going on with the mode this time? Nothing. There's none of them that are repeated, right? So in this case, we can say there is no mode. No mode. And that happens sometimes. You can have more than one mode, or you could have no mode. And then the range, biggest minus smallest, is equal to 57. So again, understand what these things mean, understand how to calculate them. The mean is really the only one you calculate. The other ones you're just crossing off to try to get to that spot. All right, type of graph, a lot of you probably haven't seen before, is called the 5-number summary. And it gives you those 5 numbers. We want to know what's the minimum, what's the maximum. Okay, that's not too bad. The second quartile is the median. And then of this bottom 50% of the numbers, the number right in the middle of those is called the first quartile. And of the upper 50% of the numbers, the median of them is called the third quartile. So we split it up into quarters, in other words. We don't know what numbers are at those spots. That's what all this is saying. Number 5 says, can you label it if it has a name? Well, if they're just numbers, there's nothing really to name it. Let's jump into this first example here on next page, practice. Maybe you're recognizing this letter A. They're not exactly in numerical order yet. Darn, so we're going to have to put them into numerical order. Let's see, 4, 7, 11, that's fine. And I think it's 16, 19, 26, and 32. So we need them in order, and I'm actually going to write them this time because I'm not just trying to find the median. And as I look at this, there are a total of 7 numbers listed. And so if I look at all 7 of them, the number that goes right in the middle, I could cross off the bottom 3 as well as the top 3. 16 is going to be right in the middle. So 16 would be our median. Below that then, this is the bottom 50% of numbers. The median of this group, so the number right in the middle of all those is 7. We would call that the first quartile. And then our minimum value, sometimes called 0 quarter, is 4. That's the starting point. So we have our smallest number, the middle of the bottom 50%. We had the number right in the middle, the median, the 50th percentile. Now we have to look at the top half of the numbers. That'll give us the third quartile and the maximum. All right, so what would be the third quartile for this one? Go ahead and turn to the person sitting next to you and can you answer that? What do you think is the third quartile? Go for it.
26.
How about this number 26? 26. And then the last thing, the maximum is 32. So here is our 5-number summary. Just gives you an idea of how the numbers are spread out. Type of way of displaying this. Example B, good news is those numbers are all in numerical order. Can you find the 5-number summary for that one? And this is a strange list because there's an even number of terms. So when you're trying to find the median, there's 6 terms below this line. There's 6 terms above that line. So here's the upper 50%. Here's the lower 50%. Our median then is a number that isn't even on this list. The median would be 5.5. It goes right in between the 5 and 6. So we'd actually average those 2 numbers together. And the mean of those 2 numbers. So our median is going to be 5.5. Now, when you look at this bottom 50%, this would be the number that, or the line that splits this bottom 50% into half. Right between 3 and 4 would be 3.5, and our minimum is 2. Looking at the upper 50%, this is where the break line is going to be. Between 8 and 9 would be 8.5. And our maximum value is 18. So there is our 5-number summary for part B. The reason why we look at this 5-number summary is to identify outliers. So I think you guys have heard the terms outliers before, but what exactly constitutes an outlier? Like if you had a list of numbers and one number looks a little different than the others, a lot different than the others, how can we say, yes, this is definitely an outlier versus no, it's not an outlier? And that gets into this next part. What we need to do is calculate the IQR, the interquartile range. We'll multiply it by 1.5, and then we'll take a look at it. So in this example A, we're going to take 26 minus 7. That's 3Q minus 1Q equals 19. That is our IQR, the interquartile range. Multiply always 1.5 times that IQR. I think that comes out to 28.5. So find the IQR, multiply that by 1.5. That's where I'm getting this number from. And then we're going to take 1Q minus 28.5, and that's this green number right here, 7. So 7 minus 28.5 is negative 21.5. Are there any numbers on our list that are smaller than negative 21.5? No, so there's no small outliers. The other thing we have to check is to see if there's any numbers that are abnormally big. So we're going to take 3Q plus that number. That's 26, our 3Q number, 26 plus the 28.5 would be 54.5. There's no numbers on our list that are bigger than that, which means we have no outliers. It didn't seem like it in this case. It didn't seem like there were any numbers that were like just really removed from all of the other ones. And so this meets the definition of not having an outlier. To part B. Try with this one. Now, as you look at this, does it look like there's any numbers that are abnormally small? I don't think so. The question is about this 18. 18 seems quite a bit bigger, but is it in fact an outlier or not? That's what you need to try to calculate. It's going to be close. I don't think it's really absurdly big, but I think it is kind of big. So can you determine if that is in fact an outlier? So interquartile range is 4. Multiply it by the standard 1.5, we get 7.5. 1Q minus that is negative 4, so there's no numbers that are smaller than this, so there's no small outliers. We didn't think there would be just looking at them. But then 3Q plus the 7.5, that's this 8.5 number plus 7.5 is 16. 18 is outside of that, which means 18 would actually be an outlier. We thought it was a possibility, and it turns out, yes, 18 is an outlier. How many of you have ever seen a box plot like one of these before? Box, sometimes called box and whisker. Anybody seen one of those before? 2 people? Yeah. So a way to display this 5-number summary, instead of just writing them as a list of numbers with words in front of them, we can make them look like this. Sometimes they're vertical. I usually see them horizontal, quite honestly. But when you see these things on the inside, this is called the box. This is the interquartile range. Here is our third quartile. Here is our first quartile. And then here is our median. So we have these numbers in the middle. They have this little box around them. And then we have this whisker or tail on going from the first quartile to the minimum and from the third quartile up to the maximum. So we'll draw one of those in a little bit here. But we should be able to interpret these to figure out like what these different important 5 numbers are. So let's just jump into our first example. We have this box plot. Notice at the bottom we have all these numbers to represent where these different numbers are on the number line at least. The first question here is, what is the median score? So as I look at this, I know that the median is coming from right here. If I draw this down, I think that this median number is about 100. I'm having to estimate a little bit because I think that's going down to 100. Next question, what IQ scores represent the middle 50%? Well, this is the first quartile. This is the third quartile. So this is the middle 50% of the data. It's going from, I'll call that 92 to about 107 maybe. And this is a bit of an approximation. But the interquartile range is going from 92 to 107. 25th percentile, 75th percentile. And then the last one says, what scores are outliers? And you'll see these 2 little asterisk marks over here, or like those little dot kind of like things. They didn't even include those on the whiskers. Normally you would, and you just see if there's a really long one, there's a chance that we're going to have an outlier. But this number looks like it's about 135. This number looks like it's about 140. And those would be considered outliers for the IQ of this group of people. Pretty high IQs, they are abnormally smart because they're not within the way that we would calculate the IQR times 1.5 to determine outliers. All right. Last thing for today. We have this list of numbers. We're supposed to find the 5-number summary and to see if there are any outliers. Step 1. Can you list these numbers from smallest to biggest? They're really jumbled up this time, so list them from smallest to biggest. Once you have them listed, can you go for the 5-number summary? Find minimum first quartile, median third quartile, and the maximum. And I'm going to pause you here for a second. We've done all these other ones just using paper and pencil. I want to show you how we can use the calculator to do some of this. Not that the calculations are that hard, but it can do some other things for us. On your calculator, if you can see where my cursor is at right now, right next to the up, down, left, right arrows, is the stat button. Go ahead and click stat. You probably haven't used this stat feature before. And the first thing we need to do is edit. So choose the edit. And your lists are probably blank right now. And what you're going to do in list 1 is list all the numbers. I already have mine in order from like putting in the numerical order from before, or you could just list them the way they were listed initially, where there was 11 and then 19 and so forth, or you can put them in the other order. It doesn't matter, but put all the numbers onto this list. Once you have all of them in there, you're going to hit stat again. So now we have our data in there. And instead of editing, we're going to scroll to the right to where it says calculate. And there's a lot of data things that we can do. We're going to choose the first one, the one variable stats. Hit enter. And it should be saying list L1. If for some reason it doesn't, you might be able to see the numbers at the bottom. They're in blue on my calculator, L1, L2, L3, and so forth. So I'd have to hit second. Then I could change that to L1 if it wasn't showing up. But I'm just going to hit enter, enter, enter on calculate. And then it gives me a lot of information. Some of this information we'll get to later. Some of it isn't as important. But this first one is significant. This X with the little bar on top of it is called X bar. It is the mean. It is the average. So we could have this do the average for us instead of having to add them together and divide by the number of terms. It's kind of nice to have it do it for us. The next three, But then this next one, it's called delta X, is what's called the standard deviation. That's a very important number to understand what it's doing, and we'll talk a little bit more about that. Knowing how to calculate it really isn't terribly significant because the calculator can do it for us, but understanding what it means is very significant if you're getting into the field of psychology, medicine, anything that deals with any kind of stats. They're going to get into talking about the standard deviation, which tells you how much different a number is from like the normal in a group of numbers. That's a really blunt way or quick way of saying what a standard deviation that it is. And then at the bottom is what we're talking about right now. It says n equals 13. That means I put 13 numbers into that data set. So if I counted them on my paper, I should see that there's 13 of them in there. And then here is that 5-number summary. The minimum is 5. First quartile is 10, median 16, third quartile, and then the fourth quartile are the maximum. So instead of having to do them on my own, again, as long as I edited them into my calculator correctly, I can find the 5-number summary from here. So there's our 5-number summary. We're also supposed to find out if there's any outliers. To do that, go back to your IQR. IQR is the interquartile range. It's the difference between 3Q and 1Q. So I'm taking 26.5 minus 10. Always take 1.5 times that number. So 1.5 times the 16.5 is 24.75. And now here is the check. Are there any numbers that are too small? So if I take 1Q minus 24.75, are there any numbers less than negative 14.75? And there aren't. Also, are there any numbers too big? So if I take this 26.5 and add the 24.75 onto it, are there any numbers on this list bigger than 51.25? And there aren't, so no outliers. And if I look at this list of numbers, it doesn't seem like any number is abnormally big or small. And I wasn't expecting it, and it turns out that there wasn't. Right, then the last thing with this one is to draw a box plot. My smallest number is 5. My biggest number is 34. I don't want to make 34 little hash marks in here. No way. Instead, I'm going to find a scale factor that works. I could pick what number. I could go up by 2s. And then if my biggest number is 34, I'd have to draw like 17 of those little marks, which isn't horrible. Or I could go up by 3s. That wouldn't be too bad. Or I could go up by 4s or 5s. Like whatever choice you choose is fine. I'm going to go up by 5s because that's, I think, an easy number to count by. 5, 10, 15, 20, 25, 30, 35. I probably wouldn't want to go up by 10s because then it'd be really hard to be very precise on that. The minimum number is 5. I'm just going to put a little dot there for right now. The first quartile is at 10. I draw this small vertical segment. The median is at 16. I'm approximating where I think that's at. Then the third quartile is at 26.5. Again, kind of approximating. We're going to draw in that box. So this represents the middle 50% of the data. And then lastly, the maximum value is 34. Put a little dot there. Connect and connect. And here is the box plot. Anytime you see like little tails or little whiskers on the end that are kind of, this is like small relative to the width of this interquartile range, I know that there's not going to be an outlier. But if there's a big segment on the outside, then there's a good chance that there's an outlier in that. So by looking at the graph, I can get an idea of what's going on there.